Variable frequency drives, VFDs, also known as variable speed drives, VSDs, or adjustable frequency drives, AFDs, are sophisticated electronic devices used to control the speed, torque, and direction of an AC, alternating current, electric motor by varying the frequency and voltage supplied to the motor. Here's a breakdown of the key components and functions of VFDs. Converter. The converter section of a VFD consists of diodes or silicon-controlled rectifiers, SCRs, that convert the incoming AC power supply, typically fixed frequency and voltage, into DC, direct current, voltage. DC bus. The DC bus smoothens the converted DC voltage, acting as an energy storage device. It helps stabilize the voltage supplied to the motor. Inverter. The inverter section of the VFD utilizes insulated gate bipolar transistors, IGBTs, to convert the DC voltage from the DC bus back into a variable frequency AC voltage. This variable frequency AC voltage is what controls the speed of the motor. Control panel. The control panel is the interface through which users can program and adjust various parameters such as motor speed, acceleration, deceleration, and direction. It usually includes a keypad or touchscreen and displays relevant information such as motor speed, current, and voltage. Sensors. VFDs can be equipped with various sensors to monitor parameters such as motor speed, temperature, and current. These sensors provide feedback to the VFD, allowing it to adjust its output to maintain desired operating conditions and protect the motor from damage. Communication interfaces. Many modern VFDs come equipped with communication interfaces such as Modbus, Profibus, or Ethernet, allowing them to communicate with other devices or be integrated into larger control systems. Advantages of using VFDs include energy savings. By adjusting the speed of the motor to match the load requirements, VFDs can significantly reduce energy consumption compared to running motors at full speed continuously. Soft start and stop. VFDs enable smooth acceleration and deceleration of motors, reducing mechanical stress on the motor and connected machinery. This feature also helps extend the lifespan of equipment and reduces maintenance costs. Precise control. VFDs offer precise control over motor speed and torque, allowing for more efficient operation and improved process control in industrial applications. Flexibility. VFDs can be programmed to adapt to changing load conditions, making them suitable for a wide range of applications across various industries. Applications of VFDs span across industries such as HVAC systems, water, wastewater treatment, manufacturing, conveyor systems, pumps, fans, and more. However, it's crucial to ensure proper installation, programming, and maintenance of VFDs to maximize their benefits and ensure reliable operation. Additionally, proper sizing of the VFD based on the motor's requirements is essential for optimal performance and efficiency. Troubleshooting procedures for VFDs. Troubleshooting VFDs requires a systematic approach to identify and address various issues that may arise during operation. Here's a general troubleshooting procedure for VFDs. Visual inspection. Start by visually inspecting the VFD and surrounding components for any obvious signs of damage, loose connections, or abnormal conditions such as overheating or unusual sounds. Check power supply. Ensure that the VFD is receiving the correct input power supply voltage and frequency within its specified operating range. Verify that there are no issues with the main power supply or circuit breakers supplying power to the VFD. Review error codes. Many VFDs are equipped with diagnostic indicators or display screens that show error codes or fault messages when an issue occurs. Refer to the VFD's user manual or documentation to interpret these error codes and identify the specific problem. Inspect motor and load. Check the motor and connected load for any mechanical issues or abnormal behavior that may be causing the problem. Ensure that the load is within the VFD's rated capacity and that there are no obstructions or binding in the mechanical system. Check parameter settings. Review the VFD's parameter settings to ensure they are configured correctly for the application and operating conditions. Pay attention to parameters related to motor speed, acceleration, deceleration times, voltage, frequency limits, and protection features. Test control inputs, outputs. Verify that the control inputs, e.g., start, stop signals, speed reference, and outputs, e.g., motor status, fault signals, are functioning properly. Use a multimeter or oscilloscope to measure voltages and signals at various points in the control circuitry. Inspect cooling system. Ensure that the VFD's cooling system, fans, heatsinks, is functioning correctly and that airflow is not obstructed by dust or debris. Overheating can cause VFDs to shut down or enter a fault state, so proper cooling is essential for reliable operation. Check grounding and shielding. Verify that the VFD and associated equipment are properly grounded according to manufacturer recommendations. Poor grounding can lead to electrical noise, interference, and erratic behavior in the VFD's operation. Review environmental conditions. Consider environmental factors such as temperature, humidity, and ambient vibrations that may affect the performance of the VFD. Ensure that the installation location meets the specified environmental requirements for the VFD. Consult manufacturer documentation. If troubleshooting efforts are unsuccessful or if you encounter unfamiliar error codes or symptoms, refer to the VFD's user manual, technical documentation, or contact the manufacturer's technical support for further assistance. It's essential to follow safety procedures and protocols when troubleshooting VFDs, as they involve working with electrical components and potentially hazardous voltages. If you're not familiar with VFDs or electrical systems, consider consulting a qualified technician or electrician for assistance. How to test IGBTs on VFD. Testing IGBTs, insulated gate bipolar transistors, in VFDs requires specific equipment and expertise due to the high voltages and currents involved. Here's a general procedure for testing IGBTs in VFDs. Ensure safety. Before performing any tests, ensure that the VFD is disconnected from the power supply and that proper safety precautions are followed. This includes discharging any capacitors and using appropriate personal protective equipment, PPE. Visual inspection. Inspect the VFD for any signs of physical damage or burn marks near the IGBT modules. Burn marks or discoloration may indicate a faulty IGBT. Check gate drive signals. Use an oscilloscope to measure the gate drive signals applied to the IGBTs during operation. The gate signals should exhibit the correct waveform and timing. Abnormalities such as distorted waveforms or missing pulses may indicate a problem with the gate drive circuitry. Check resistance. Measure the resistance across the terminals of each IGBT using a multimeter. The resistance should be within the manufacturer's specified range. A significantly higher or lower resistance than expected may indicate a faulty IGBT. Check diode functionality. IGBT modules typically include built-in freewheeling diodes. Use a multimeter to check the forward and reverse voltage drop across these diodes. The diodes should conduct in one direction and block in the other direction. Any short circuits or open circuits indicate a faulty diode. Perform IGBT dynamic test. Some specialized test equipment allows for dynamic testing of IGBTs under simulated operating conditions. This involves applying controlled voltages and currents to the IGBT while monitoring its behavior. Any deviations from expected performance may indicate a faulty IGBT. Inspect thermal management. Overheating is a common cause of IGBT failure. Ensure that the VFD's thermal management system, including heatsinks and cooling fans, is functioning correctly. Insufficient cooling can lead to thermal stress and premature failure of the IGBTs. Compare readings. If the VFD contains multiple IGBT modules, compare readings across all modules. Consistently abnormal readings in one module compared to others may indicate a faulty IGBT. Consult manufacturer documentation. Refer to the VFD's user manual or technical documentation for specific testing procedures and recommended diagnostic tools. Some manufacturers may provide specialized diagnostic software or tools for testing IGBTs. Replacement. If a faulty IGBT is identified, it should be replaced with a new one of the same specifications. Ensure that proper handling and installation procedures are followed to prevent damage to the replacement component. It's important to note that testing IGBTs in VFDs requires expertise in electronics and power systems. If you're not familiar with these systems or lack the necessary equipment, consider consulting a qualified technician or contacting the manufacturer's technical support for assistance. Additionally, always follow appropriate safety precautions when working with high-voltage equipment.